So for the next session, we've got Rachel, and she's going to be talking about accessible apps. And then you are going to be hosting the next few hours.
I'll be around hanging out with our .NET Conf friends for the next few hours. Absolutely.
All right. Well, let's bring Rachel on. So welcome, Rachel.
Hi. Hello,
Hi. Well, it was great. You were on, we had a Let's Learn.net with accessibility, and you taught me so much cool stuff there, and I'm excited to see what you've got for us now.
That's right. I'm glad you were able to check that out, and I'm glad to be back today on .NET Conf.
Okay, well, I'll turn it over to you.
Sounds great. So hi, everyone. For those of you who don't know me, I'm Rachel. I take she, her, hers. I'm a Korean American woman with mid-length dark brown hair, and today I'm wearing like a pinkish salmon colored shirt, and I have a virtual background with a 3D .NET bot floating in space. And today I'll be chatting with y'all about building accessible apps with .NET MAUI. But before we jump into it, I always like to start with a little refresher about accessibility to remind ourselves why we love and care about accessibility so much. So, as a reminder, there are over 1 billion people currently experiencing some form of disability. And at Microsoft, we have tools like the persona spectrum that help us to understand the scope of this. So disabilities can be permanent, temporary, or situational, and they range across a wide range of abilities, like the ability to touch, see, hear, speak, and so much more. And so naturally, designing for accessibility is also not limited to people experiencing disabilities, and the best solutions actually benefit everyone. So, for example, we have closed captioning in Teams and a lot of other places in our world, the raise hand feature in Teams. Our devices come with the ability to set our light and dark or different themes. Even in the physical space, we have things like dropped curbs and sidewalks. So you can see that these are all examples of things that were accessible solutions, but they're all things that everyone benefits from in our day-to-day. Beyond this, there's also a huge business opportunity worth hundreds of billions that you'd be missing out on if you neglect accessibility. And of course, in our growing digital age, there's also a growing number of legal consequences that you can run into if you neglect to keep accessibility in mind. So how can we approach accessibility in our apps? Well, empathy is always going to be the name of the game. It's always about understanding and empathizing with our customers and the experiences, their various experiences that they have. And when it comes to understanding our users with different disabilities, it's really helpful to explore the various accessibility settings and features that devices offer. So for example, screen readers like Narrator on Windows, TalkBack on Android, VoiceOver on iOS, various device theming settings, font size settings, color contrasts, guidelines, etc. It's also helpful to research a variety of accessibility models and APIs, and of course, to test and leverage available tools and resources. And we'll be going more in depth into all of these things today. And with .NET MAUI, you'll be able to create accessible apps more seamlessly than ever before. And this is just a sampling of a bunch of PRs we've worked on in order to make .NET MAUI the most accessible framework you've ever seen. And in working towards .NET 7 alone, we actually closed more than 35 bugs for accessibility. So that's pretty awesome. So without further ado, I want to talk to you all about 10 awesome things about .NET MAUI accessibility, in no particular order because I love them all. Number 1, we have semantic properties. So semantic properties are a new set of accessibility APIs in .NET MAUI, and they are particularly helpful with the screen reader experience. If you're not familiar with screen readers, they are an assistive tool that allow users, especially with visual impairments or who are blind, to understand what our apps are providing them without seeing the visual cues. So our screen readers read aloud what's on the screen, and we have these semantic properties in .NET MAUI to set a description, a hint, and a heading level, all things that enhance the screen reader experience, and we'll go more in depth in later. But for example here, if you have an image, if you don't have the visual cue of being able to see what the image actually looks like without informing our screen reader of what it should read aloud, there's no way for folks to know what the image represents. And so you can use semantic properties.description to set a description to the image. And a lot of people like to think of this property as an alt text, for example. Number 2, semantic extensions. So we have more awesome APIs for accessibility in addition to our semantic properties. For example, we have a set semantic focus that allows developers to have more control over where the screen reader focus should go. There's also a semantic screen reader.announce method that allows developers to provide a description that should be announced by the screen reader, and it doesn't necessarily need to be associated with a specific control as the semantic properties on the previous slide did. And then next we have our community toolkit. So community toolkit is an extension of Xamarin Forms and .NET MAUI. So we have Xamarin Community Toolkit, which can be used with Xamarin Forms apps. And now we have MAUI Community Toolkit, which can be used with .NET MAUI apps. And with Xamarin Forms Community Toolkit, we had semantic effects and semantic order view. Semantic effects allows folks to leverage the .NET MAUI semantic properties in your Xamarin Forms apps while you're still working on migrating over to .NET MAUI. And there's also semantic order view, which will also be included in MAUI Community Toolkit. And this allows developers to have greater control over screen reader navigation order. And we'll go more into this later, hopefully, as well. Number 4, app theming. So in .NET MAUI, we have the capability for folks to set different app themes of your choosing. You can set your own styles and use app theme bindings to use all the different colors you wish to use as long as they are accessible. And right out of the box here with a file new MAUI app, you can see that it supports light and dark modes with the appropriate accessible color contrasts. Number 5, font auto scaling. So our awesome devices give us the capability of controlling the font size that we want our apps and various things on our phone to use. But if you don't ensure that your apps support this capability, it won't actually work. But in .NET MAUI, we ensure that on Android and on iOS that this feature, this auto scaling of the fonts is enabled right out of the box. And if for some reason there's something on your screen that you think would be better not to be auto scaled, then we also have a property font auto scaling enabled that you can set to false for those rare scenarios. Number 6. So I've been talking a lot about our various accessibility APIs with semantic properties and semantic extensions. And beyond all of those awesome APIs, we, with .NET MAUI, wanted to build in as much accessibility as possible, so you don't even need to really think about adding more code to make it more accessible. So a couple of examples of that. For example, here we have the tap gesture recognizer, which we added some accessibility traits to. So if you add a tap gesture recognizer to a control, essentially that means that the control is going to act like a button. And so we wanted to ensure that the screen reader experience reflects that as well. And so with these accessibility traits now, the controls with a tap gesture recognizer will read out double tap to activate. And similarly, another example of this is with our checkbox. So in .NET MAUI, we have a bunch of cross-platform controls, including controls that aren't normally supported on specific platforms. And checkbox is an example of a control that doesn't normally exist on iOS. But with MAUI, it does. And so we wanted to make sure that even though it's new to the platform, it remains accessible. And so it reads out as a switch, which is the iOS equivalent experience. So thank you, Shane, my awesome teammate, for working on these two and so much more. Number 7, we have the ability to customize .NET MAUI code via handlers. So this is something that you can do with really anything in .NET MAUI, but also in accessibility. How awesome is that? So all of our controls in .NET MAUI implement interfaces that are associated with handlers on iOS, Android, and Windows. And the awesome part about that is that it extends our capabilities beyond .NET MAUI to really be able to do more. So you can tap into these mappers to add custom code for the specific platforms you might be familiar with. So you can use our compiler directives for Android, iOS, Catalyst, or Windows to further extend the capabilities of your apps beyond .NET MAUI. How cool is that? Number 8, accessibility standards. The cool thing about using .NET MAUI is that you have the capability of meeting accessibility standards right out of the box. As we are part of Microsoft, we comply with the Microsoft Accessibility Standards, which comprises of the Web Content Accessibility Guidelines and other global standards for accessibility. So that means that with .NET MAUI, you can meet these Web Content Accessibility Guidelines and your apps will be perceivable, operable, understandable, robust across the board. Number 9, accessibility insights. So this is one of my favorite tools, and it is a Microsoft offering that all of you also have access to. It's currently available on Windows and Android, and this is a tool that was helpful for us in working with .NET MAUI and building it out as well. So here you can see that the tool told us that this purple .NET bot against a purple background did not have a sufficient color contrast. So this was an initial version of what we had in our templates, but we've since changed the colors to be more accessible. So we have a white background with a purple .NET bot against it, which meets the color contrast requirements. And we have a happy cat here that tells us, congratulations, nothing else to review. And beyond our templates, we've also run the accessibility insights on our recipes app, which is a more involved app leveraging more of .NET MAUI's capabilities. We've run that through accessibility insights. We've also had a team of accessibility experts run through everything to ensure .NET MAUI is as accessible as it can be. Before we go to number 10, it's time for a demo. So I want to show you some of, all the cool things that I talked about. Okay. Alrighty here. So here I have a file new .NET MAUI app, and I already have it running. So it looks like this. So we have here, let me run it again, actually. All right, but we have here an image of a .NET bot. We have a description that says, cute .NET bot waving hi to you. We have a label that says, hello world, heading level. And we have another label that says, welcome to .NET Multi-Platform App UI. We have heading level here and a description that we set. And we also have a button at the bottom that says, click me, and has a hint that says counts the number of times you clicked. So I'm gonna turn TalkBack on so y'all can hear what our screen reader is saying and how these semantic properties actually come into play. So for our image, you'll see that this description is read aloud by TalkBack. Let me turn TalkBack on.
TalkBack on. Held volume keys. TalkBack turned on. Permission request.
All right, so I'm gonna click on the image here.
Cute.NET bot waving hi to you, image.
So it tells us it's a cute.NET bot waving hi to you, as that's the semantic description that we set. It tells us it's an image. If we move on to the next label, it'll read out hello world.
Hello, world, heading.
It also tells us it's a heading since we set a heading level on it. And heading level and headings is a way for screen reader users to navigate through content quickly, especially if there's a lot of components on the screen. So there's a mode where you can navigate just through the headings, which is kind of like a table of contents of sorts and is really helpful. So next we have another label. So if I go click on that one.
Welcome to .NET Multi-Platform App UI, heading.
It also reads out the text, and actually I set a description on this one, which for text-based controls you normally don't need to, but I wanted to do it here in order to ensure that the label is read out exactly as I wanted to. I wasn't sure how the screen reader was going to interpret .NET with the period net. So I wrote out literally the word dot and net and so on. And as before, you saw that it was announced as a heading. And then last but not least, we have a button here.
Click me button counts the number of times you click.
So the text is read aloud.
Double tap to activate.
Click me, the hint is read aloud. It tells us the purpose of the button. It counts the number of times you click, and it tells us to double tap to activate. And if we look at the code behind here, when we click the button, it will not only increase the count of the button, but it will announce for us here the text of the button again to keep us updated, since I included the semantic screen reader.announce method. So I'm going to double tap to activate.
Clicked one time.
And the updated text is read aloud right back to us. So right out of the box, you can see how we already have all of these awesome accessibility features baked in. So another thing I wanted to show y'all was the tap gesture recognizer feature that I mentioned. But actually, before I do that, I want to show you accessibility insights. So that was the awesome tool I showed you. And here I have accessibility insights open, and it's connected to my physical device, my Pixel 4a, which I've been using to demonstrate with y'all. And we're going to start testing. And when I hit start testing, it's going to open the window you saw in the PowerPoint, and it's going to show the screen that we're working with. Tells us there's no failed instances, nothing needs review, we're all good to go. So you can see for yourself here that we are truly accessible. It's not just me saying things. Okay, so back to what I was saying with the tap gesture recognizer. Let me stop the app first. So here I'm going to add in a label that looks exactly like the button. I have a label here with the same exact text, same exact hint as the button, and I added some other properties to make it look like the button visually. But it's not a button, it's a label, and I'm going to add a tap gesture recognizer to it. And I'm doing that in the code behind here with this onCounter label clicked method. So I have a new tap gesture recognizer that I instantiated. I added the same exact logic from the onCounter clicked method being used by the button. And then I added the tap gesture recognizer to it. And then I'm going to call on that method. And then I'm going to run it again. And as I mentioned to you before, even though we didn't add any extra accessibility capabilities to it here, because of the way we built .NET MAUI to be accessible, that tap gesture recognizer will be recognized as a clickable component by screen reader as well. So it's running up again. I'm going to turn talk back on. So we have here the original button.
Click me button counts the number of times you click. Double tap to activate.
So it tells us click me, it's a button, counts the number of times you click, and then double tap to activate. The label should be similar. So if I go to the label,
Click me counts the number of times you click. Double tap to activate.
it says click me, counts the number of times you click, and then double tap to activate. It doesn't say it's a button because it's technically not a button, but you can still double tap to activate it. So that's super cool. Another awesome thing I wanted to show you an example of was the handler stuff that I mentioned to you before. So there was a fun issue that someone reported in .NET MAUI recently about tab navigation on Windows. So they said the tab button does not work when you shift button from the last button. So I don't know if I had a screenshot here. But basically what they were saying was that when you have multiple buttons on a Windows app, when you use the tab key on your keyboard, you can tab to the next one, but you can't press tab again to navigate up backwards. And so we investigated and we found that actually that is the default behavior on Windows. If you want to use your keyboard to go back to a previous button, then you have to press Shift Tab. But pressing tab alone wasn't going to get you back to a previous button. But we wanted to see, is there a way we can make that possible? And we found that you can actually do that in WinUI, because WinUI has a tab focused navigation property that we don't actually offer currently in .NET MAUI. And you can set it to an enum of having keyboard navigation mode .cycle. And by doing so, you can achieve the behavior that this customer was looking for, even though it's not actually something currently offered in .NET MAUI. So I want to show you how we did that. So let me comment out the tab gesture recognizer stuff we were just looking at, and I'm going to comment in this awesome tab navigation custom handler code. So here, I'm going to go to our Target Framework menu, switch to Windows, and go launch our MAUI app on Windows now. And so you can see here, all I did is I added 2 of the same button. And in the code behind, we have this modified tab navigation method that I created, and I'm using the Windows compiler directive to say, hey, on Windows, let's leverage their tab focus navigation property and set it to the enum of keyboard navigation mode.cycle, so that when we press the tab key, it'll go to the next button, but it also cycle back to the previous one as this customer wished. So when I hit the tab button, it'll go to the button, and then when I click it again, it'll go back up, and it'll keep going back and forth. So that's an example of an awesome way you can leverage our handlers to extend the capabilities of .NET MAUI to make it even more accessible however you wish. Alrighty, so there's some time left. So another thing I wanted to show you actually is the semantic order view stuff that I had mentioned before. Let me see if I can go back to the slide so that you can remember what I'm talking about. Here, so in the community toolkit, I mentioned semantic order view as something that we offer. And with semantic order view, you can control the screen reader navigation order. So here we have a stack layout with labels and buttons. And normally the screen reader focus order would go in the order that it is programmed, which makes sense. But there are some rare scenarios in which you might want to have it read in an order that is different from the programmatic order. And so with the semantic order view, you can do this by setting names on each of the controls that you are using, and then creating a list of those controls in the order you want them and setting that to the semantic order view order. Okay. Ooh. So back to my device here. I have the Xamarin Community Toolkit, and I'm going to go to Views and then to Semantic Order View. And you can see here I have exactly what that sample code reflected, but I also have an element at the top here that's actually outside of a semantic view. So what we should see happen is the focus will first go here, and then it'll go down to first, since we just, as an example, said that the last element should be focused on first, and then it'll jump back up to this label that says second, button that says third, label that says fourth, and then the button that says fifth and last. So I'm going to turn talk back on. And I'm going to
held volume keys.
Then I'm going to navigate just by one finger swiping through, and that should go in the order that we want it to. So there we
Semantic
go.
element outside the semantic view button.
And then it should jump all the way
Double tap to
down.
activate. First button.
And then back
Double
up.
tap to activate. Second, third, fourth, fifth, and last button.
So
Sound settings.
voila. So that's another capability in our community toolkit that you can leverage in your apps. All right, I'm going to jump back into my slides, which kept getting all over the place. Sorry about that. All right, so we did the demo, and now number 10, the journey continues. So you can all go and build accessible apps with semantic properties. We have all this awesome documentation about it. And we also have a blog post series that you can check out to learn more. And we're going to continue working on this. So this is how you can all stay updated with us. You can also join our Discord and chat with us in the Maui-accessibility sub-channel to stay tuned with how we continue to grow in our accessibility journey. So thank you, everyone. You can follow me on Twitter and chat with me there as well at the Rachel King and see what we're up to, as I mentioned, on Discord and, of course, GitHub.
Oh, Rachel, thank you so much for sharing. There's a lot to pick up there. There's a lot going on with accessibility when we think about our mobile applications and what we can do with them. Now, I mean, I'm a web developer, and when I get in and I start looking at Maui, I think of the Blazor hybrid model. Is that something that is supported with some of those accessibility checker tools you were showing?
Yeah, absolutely. So the Blazor team, just like the .NET MAUI team, they're also working on accessibility just as hard as we are. They also have the same process of working with accessibility experts with Microsoft and ensuring that they are meeting those accessibility requirements.
Very cool. There's a question I have here from Jose on YouTube asking, are there any benefits for apps with accessibility support provided by the app stores or provided by search engines for websites that have accessibility support?
Would you mind repeating that question? I'm not sure quite.
Sure. Let me read it again here. Are there any benefits for apps with accessibility support provided by the stores? So I guess the stores apps, do they provide accessibility in their search or websites that have accessibility support? I'm kind of lost on that question, Jose.
So I'm not exactly sure I understand the question properly, but I think based on the team of developers who is developing the app, the accessibility and how much they have accessibility in mind, the accessibility of the app will naturally vary. That being said, the App Store apps themselves and any apps created directly by Android and Apple and Microsoft, respectively, tend to be accessible because they all have similar processes to ensure that they are meeting these accessibility standards.
Very cool. And I feel like we're right at the start of some of these things. We're still learning and growing, and having these tools available to us really is a good education point for all of us to jump in and start improving our apps. Thank you so much.
Yeah, absolutely. Thank you all so much. And absolutely, it's a learning journey. So please stay in touch.
Will do. Thank you so much, Rachel. We're going to say goodbye to you and get ready for our next session.